Artificial intelligence is fundamentally changing how operational work gets done. But while most teams are racing to automate, they are walking into a massive trap. We call it the architect's trap. It is the moment your theoretically perfect, scalable database scheme collapses under the weight of real-world AI workload. When your pipeline becomes a black hole, AI automation actually sinks your revenue before the project even starts. Today, we are breaking down why this happens. Welcome. I'm Alex. In this session, we're exploring the structural failures that kill AI scaling and how you can build a system that actually survives production. To understand why these systems fail, we have to look at the mismatch between legacy architecture and the explosive demands of modern AI pipelines. Most architects build for a future that never arrives. They optimize for massive storage, while ignoring the high-frequency operational bottlenecks happening right now. As the workload increases, these rigid schemes lose their efficiency. You end up with a bottleneck that no amount of cloud computing or hardware can solve. This matters because speed is the only real currency in the AI economy. If your system can't respond in real time, your automation becomes a liability, not an asset. AI agents require a level of data velocity that legacy databases were never designed to handle in a single, high-frequency execution session. The core issue is a fundamental mismatch in data velocity. AI agents consume and produce data at speeds that break traditional relational models. Relational databases were built for human speed interactions, forms, clicks, and page loads. AI agents interact with data thousands of times per second. Traditional schemes optimize for storage efficiency. They want to save every byte, but AI automation requires optimization for real-time inference and state. If every AI decision requires a database lock or a complex join, your entire workflow slows down to the speed of your slowest disk operation. Let's break down the core concept of stateful automation. In simple terms, your AI needs to remember where it is without asking a central server every time. If your AI agent is stateless, it has to fetch context for every single token it generates. That's thousands of unnecessary round trips to your database. The solution is decentralized state management. We give the AI the specific context it needs to execute right at the point of processing. This allows your automation to scale horizontally. You aren't limited by a central bottleneck, but by the distributed power of your entire network. To see this in action, let's look at a practical example. A large-scale e-commerce logistics platform handling millions of daily package updates. Every package update is a data point. Traditional systems often struggle or crash when 10,000 updates hit the same database table at once. By using AI-localized state, each package event is handled independently. We batch the updates to the main database, preserving critical system resources. The result was a 90% reduction in database latency. The system stayed up during peak traffic hours while reducing operational costs significantly. Ignoring this architectural shift is the greatest risk to your revenue today. Scaling a broken system only makes the eventual failure more expensive. The market does not wait for your technical debt to clear. If your competition processes data 10 times faster, they will out-innovate you before you can react. Every day you spend maintaining a legacy architecture for AI workloads, you are adding to a debt that will eventually bankrupt your operational efficiency. Your first actionable takeaway is simple. Design for flow, not just for storage. Your system should be a river of data, not a stagnant reservoir. This means rethinking how data enters your system and how it is consumed by AI models. Minimize friction at every point in the pipeline. If this breakdown is useful, please like the video and comment automation. It helps us bring more practical AI workflows to the engineering community. Subscribe if you want to see how we build these systems from the ground up, including the code and the infrastructure maps. Now, let's keep moving. We are moving away from the monolithic database and toward what we call a distributed intelligence layer. This is the heart of modern AI architecture. This layer caches state, manages agent memory, and ensures that your core database is only touched when absolutely necessary for record keeping. Processing at the edge is critical. The less distance your data travels to reach the AI model, the lower your latency and the higher your reliability. In a production environment, 100-millisecond delay is the difference between an AI that feels like a tool and one that feels like a failure. Let's compare a traditional manual workflow to a modern AI-assisted one. The difference isn't just speed, it is structural efficiency. Manual processes wait for human input. Data sits idle in queues, losing value every second it is not processed. This is where most revenue leaks occur. In an AI-assisted flow, the bottleneck shifts to the system, but because the system is code, we can optimize it. We can scale the brain without adding more people. When you remove the human wait time, you unlock 10 times the throughput, but only if your database doesn't become the new human bottleneck. The human role in this new architecture isn't execution, it is governance. We stay in control by defining the guardrails and the logic. We set the confidence thresholds. We decide when the AI needs a human eye and when it can proceed at full speed without our interference. This is how you manage outcomes at scale. You aren't checking every transaction. You are monitoring the system that manages the transactions. This high-level governance is the only way to maintain quality control while achieving the explosive growth that AI automation promises. The final trap is thinking you can just add AI to an old, monolithic database. It simply does not work that way. You have to rebuild for reality. You can't put a jet engine on a horse-drawn carriage. To get the benefits of AI, you must modernize the chassis of your data infrastructure. Start with an audit. Where are your hot tables? Where is the AI waiting for a lock? Mapping these latencies is the first step toward a solution. Then, begin moving state to the edge. Implement intelligent caching and start decentralizing your critical path. Don't let your database hold your revenue hostage. When your architecture matches your ambition, the results are exponential. You'll see higher uptime, lower costs, and a more resilient business model. The future belongs to the architects who understand that data is for use, not just for storage. We are building the nervous system of the modern enterprise. In the next 5 years, the database as we know it will become an invisible background layer, while the intelligence layer drives every decision in real time. The question is your system ready for that future? Or are you still building for a world that no longer exists? It's time to make a choice. To recap, optimize for data flow, decentralize your state management, and focus on managing high-level outcomes rather than micromanaging entries. Audit your systems today. Identify the bottlenecks before they become catastrophic failures. Empower your AI agents with the architecture they deserve. If you found this strategic breakdown useful, please share it with your engineering team. This is a conversation we all need to be having right now. Comment "Build" if you want more deep dives into software engineering and AI infrastructure. Your input drives the topics we cover next on this channel. Subscribe to stay ahead of the curve. I am Alex, and I will see you in the next breakdown. Thank you for watching, and good luck building your future.